When we gaze upon the colossal stones of Baalbek, the perfectly interlocked walls of Sacsayhuamán, or the iconic circle of Stonehenge, the question is inescapable. How did ancient builders transport and position blocks weighing up to hundreds of tons? Historians and archaeologists have offered countless theories, from endless manpower to massive earthen ramps. But so far, no explanation comfortably accounts for the consistent features found at these sites: protruding knobs, deep plug holes, and evidence of repeated controlled burning. Instead of dismissing these features as ritual or decoration, what if they were all part of a lost but astonishingly practical lifting technology? At the heart of this theory is a deceptively simple idea: fire creates lift. Anyone who has watched smoke rise knows that hot air can carry material upward. Early peoples, perhaps inspired by simple campfires, may have realized this natural buoyancy could be harnessed to partially counteract the enormous weight of stone. With an understanding of how hot air could fill a sealed envelope, they could have constructed primitive balloon-like structures, aerostats, to lighten loads that otherwise seemed immovable. These primitive balloons would have relied on three key elements, all documented across ancient construction sites. First was the heat source itself. Evidence of fire pits, scorched platforms, and burned soil is found consistently near transport routes and staging areas. Second was the balloon envelope, made from hides, woven linen, or even early composites treated with resins to resist heat and seal leaks. And third were the anchor points, the knobs and plug holes carved into the stones, strategically placed to stabilize and tether the lift assist rig. The beauty of this system was that it did not require the balloons to lift the entire mass of a block. Even a partial lift, reducing the effective weight by 20% to 40%, could change a problem of unmanageable friction into one where people, oxen, or elephants could drag a stone across rollers with surprising efficiency. Knobs placed at corners or balance points allowed ropes to distribute tension evenly, preventing the block from spinning or tipping as it moved. Plug holes accepted beams or frames to further stabilize the rig and the balloon. In Egypt, this knowledge appears to have evolved into a mature, systematized technology. Old Kingdom builders worked with finely woven linen, treated with oils and resins to tolerate high heat. They designed more advanced fire systems, using multiple controlled heat sources to channel air safely into balloon envelopes, avoiding direct flame contact. With these improvements, engineers could manage larger stones and develop more aggressive transport slopes, speeding up pyramid construction and enabling the delicate raising of obelisks. One of the most elegant uses of balloon technology was in tipping an obelisk from horizontal to vertical. The challenge was not just the weight, but the risk of breaking the tapered stone under its own stress. Balloons along its length could partially offset its mass, while ropes controlled the pivoting motion. Plug holes and knobs allowed workers to balance tension dynamically as the obelisk stood up, creating a slow, controlled float, rather than a dangerous, brute force lift. At Baalbek, however, the sheer size of the trilithon stones, over 800 tons each, seems to exceed even Egypt's improved hot air balloon approach. Here, the theory expands into new territory: the possibility that naturally emerging hydrogen from geothermal vents like those near Baigong in western China may have been harnessed instead. Hydrogen's lift is far superior to hot air, allowing a balloon to achieve several tons of buoyancy per cubic meter. Combined with ancient silk, incredibly strong, light, and sealable, a hydrogen balloon could, in theory, lift a significant portion of even the heaviest megaliths. The possibility of silk hydrogen technology reframes the timeline of technological evolution. Instead of seeing balloons as a modern or even 18th century novelty, we could see them as an innovation reaching far back, perhaps even 200,000 years, when conditions at Baigong suggest human presence. If so, then Baalbek's megaliths become not an impossible riddle, but the result of a now vanished mastery of gases, materials, and lift mechanics far beyond what mainstream archaeology accepts. Whether in Egypt or Lebanon, balloons changed the ancient world by enabling not just movement, but precision. When heavy stones were partly buoyed, they could be placed with millimeter-level accuracy, a requirement for walls and platforms that still lock together perfectly after thousands of years. The same systems that floated stones could pivot, rotate, and adjust them before final placement. Far from brute labor, these were acts of advanced engineering, elegant, efficient, and repeatable. Ultimately, balloons changed the world by expanding the horizon of the possible. They turned campfire smoke into an industrial principle, animal hides and silk into powerful lift devices, and simple knobs into precision anchors. If even part of this theory holds true, then balloons deserve recognition not as mere toys of the modern era, but as one of humanity's oldest and greatest technological allies. The tool that helped raise civilization, quite literally, stone by stone.